beep, bop, whir. Step right up, step right up. Welcome to the grand opening of Ziggy's Super Duper Snowflake Factory.
Wow, Ziggy, that's a really big machine for something so tiny. What does it do?
It solves the biggest problem with winter, Emma. Nature is so disorganized. Beep. My machine makes snowflakes that are squares. Perfect, stackable squares. Look.
That looks like a tiny frozen cracker, Ziggy. But aren't real snowflakes supposed to be, pretty and pointy? And definitely not square.
Hoot hoot. Emma is quite right, Ziggy. While your organized snow squares are very creative, real snowflakes are masterpieces of nature. And here is the most magical part. No two of them are exactly alike.
Does not compute. Does not compute. How can zillions of snowflakes fall from the sky and never repeat a design? That would take a supercomputer bigger than my brain or my hard drive.
That is a good question, though. Dr. Owl, if snow is just frozen water, why doesn't it all freeze into the same ice cube shape? Why are they all different little stars?
An excellent observation, Emma. It is one of winter's greatest mysteries. To solve it, we must shrink down to the size of a speck of dust and take a wild ride through the clouds. Hoot hoot! Welcome to STEM with Dr. Owl. I am Dr. Owl, your wise guide to the wonders of science.
And I'm Emma. I'm here to ask all the big questions and explore the world with you.
Ziggy here, your friendly neighborhood robot who loves science and holiday cookies. Beep.
Together, we take you on exciting STEM adventures to discover how our amazing world works.
It's getting chilly, Dr. Owl. That means the holidays are coming.
Indeed, and our team will be taking a short winter break to recharge our feathers and batteries from December 22nd to January 2nd.
But don't worry, we will be replaying some of our favorite past episodes during the break, so you can still learn cool stuff while you sip hot cocoa.
Wait. Before you go.
Ziggy? Why are you huddled in the corner holding a single flickering flashlight?
I am the little match robot. Beep. Out here in the digital cold with only my last % of battery.
Oh boy, here we go.
I see visions in the light. I see your cousins. I see your grandma. I see your pet hamster. They are all listening to our podcast. Please make the vision true. Share the show. Warm my rusty circuits with your friendship.
Oh, a very dramatic performance, Ziggy. But the sentiment is true. The best holiday gift you can give us is to share STEM with Dr. Owl with your friends and family. It truly helps us keep the lights on in the lab. Happy holidays!
Happy holidays!
Welcome back, curious explorers. Today, we are answering Emma's frosty question. Why are all snowflakes different? And how do they get those beautiful shapes?
I'm holding my hand out, trying to catch one right now. Okay, Dr. Owl, start at the beginning. What is a snowflake actually made of? Just plain old water?
Almost, Emma. It starts with a recipe. Every snowflake begins as a tiny, microscopic piece of dust or pollen, floating high up in the clouds.
Dust? Ew, I thought snow was clean.
It is very clean. Ziggy, the dust is just the anchor, the seed. Water vapor, which is water that is floating in the air like a gas, bumps into that dust speck and freezes instantly. It turns into a crystal.
A crystal? Like a diamond?
Similar. This brings us to our very first trivia challenge. I want everyone listening to guess.
Lay it on me.
Water freezes to turn into ice, but at what temperature does that happen? Is it A, 100 degrees Fahrenheit? B, 32 degrees Fahrenheit? C, when the water gets tired of swimming?
Oh, I know. It's C. The water gets sleepy and takes a nap. Snore beep.
Ziggy, water doesn't sleep. I think the answer is B, 32 degrees Fahrenheit. That's 0 degrees Celsius for our friends using the metric system.
Correct, Emma. When the air is 32 degrees or colder, that water vapor freezes onto the dust speck. Now, here is the secret to the shape. Water is made of molecules called H2O.
H2O? That sounds like a robot name. No offense, Ziggy.
None taken. H2O sounds like my cousin R2O.
Ho-ho! H2O stands for 2 hydrogen atoms and 1 oxygen atom. When they freeze, they hold on to each other in a very specific pattern. They love to form a shape with 6 sides.
6 sides. Like a hexagon?
Precisely. Explorers, can you say that word with me? Hexagon. It's a shape with 6 corners. Because of the way water molecules hold hands, snowflakes almost always have 6 arms or 6 sides.
Wait, I tried to make an 8-armed snowflake once. It looked like a frozen spider. It was terrifying.
That is because nature follows the rule of 6 for water crystals. But, Emma, to answer your big question about why they are all different, we have to look at their journey.
Their journey? You mean falling from the cloud?
Exactly. Imagine a snowflake falling from the sky is like walking through a giant invisible maze. As it falls, it passes through different pockets of air. Some air is warmer, some is colder. Some air is dry, and some is wet.
Oh, I think I get it. So, if it goes through a wet patch of air, maybe the crystal grows faster?
Spot on. We call the wetness in the air humidity. If there is high humidity, the snowflake grows long, fancy arms. If the air is drier, it grows simpler shapes, like flat plates.
So, the snowflake is changing its outfit depending on the weather it bumps into?
That is a wonderful analogy, Ziggy. And because the wind blows every single snowflake on a slightly different path, no 2 snowflakes experience the exact same mix of hot, cold, dry, and wet air.
Wow. So because their trip down to Earth is different, their shape ends up different. It's like a diary of their travel.
Beautifully put, Emma. Now let's see if our explorers are paying attention. It is time for a game I call Real or Ziggy Flake.
Beep bop. I hope the Ziggy Flakes win.
Explorers, I am going to describe a shape. You yell out real if it sounds like a nature snowflake, or Ziggy Flake if it sounds fake. Ready? Round 1. This snowflake has 6 beautiful branches that look like fern leaves, and it is perfectly symmetrical, meaning one side looks just like the mirror image of the other.
That sounds real.
Correct. That is a classic stellar dendrite crystal. Round 2. This snowflake is shaped exactly like a perfect circle, smooth as a ball.
Ooh, that's a Ziggy Flake or a snowball.
Ho ho! It is a Ziggy Flake! Snow crystals have angles and corners. They are rarely perfect circles. Round 3. This snowflake is shaped like a tall, thin column, almost like a tiny pencil.
That sounds weird. Maybe a Ziggy Flake?
Ah, tricky one. that is actually real.
What? A pencil snowflake?
Yes, when it is very, very cold, snow can form as needle or column shapes. They don't always look like stars.
My mind is blown. Or my processor is overheating. Beep fizz.
So, we learned that snowflakes are made of water vapor freezing onto dust. We learned they love the number 6. And we learned that their shape changes based on the temperature and humidity they float through.
It makes me want to catch them on my tongue even more now. It's like tasting a little story from the sky.
And if you catch one on your tongue, you are eating science. Beep.
Indeed you are. Before we go, I have one last think about it for our explorers. Since every snowflake is unique, just like every person is unique, what makes you different from everyone else? Is it your laugh? Your ideas? Or maybe the way you build snow forts?
That's a great question, Dr. Owl. I think my snowflake specialness is that I ask a lot of questions.
And mine is that I can turn into a toaster. Wait, no, I can't. I just get really warm when I think too hard.
Ho ho ho! Stay curious, my snowy scientists. And next time you see snow falling, remember, you are walking through a gallery of millions of tiny, unique masterpieces.
Thanks for explaining, Dr. Owl. Bye, explorers. Stay warm.
Bye-bye. See you next year and happy holidays. Beep. Hey, Dr. Owl, Emma, look. I caught the world's most perfect snowflake. I named him Flaky.
Aw, he must be beautiful, Ziggy. Where is he?
I put him in my pocket to keep him safe and warm.
Oh, Ziggy, warm pockets and ice crystals do not mix.
Let me just check. Huh? Flaky, you're gone. And my pocket is soggy.
I think Flaky melted, Ziggy.
No, he was so young. He had so much potential. Now he's just wet beep soap.
That was so much fun, Dr. Owl. I hope all our explorers had a great time, too.
Hoot hoot! We loved having you with us. If you don't want to miss our next adventure, follow us on your favorite podcast platform.
And if you know a friend who loves exploring, too, share our podcast with them.
If you have a question or a topic you want to learn more about, leave us a comment. See you next time.